Today I have this micro ATX motherboard. This is GIGABYTE B550. This board is completely dead. It doesn't power on and shows no reaction to the power button. I have already removed the heatsinks, but I haven't taken a look at this yet. Let's look at this together and see if we can get it fixed. Let's check resistances on power inputs. The best way to do it is on the main power header. This is a large 24-pin male header. If we detect a shorted rail here, we shouldn't try to power this board on. 3.3 volts, kilo ohms, 5 volts, kilo ohms, 12 volts, kilo ohms, minus 12 volts, no short. This coil, I guess, is a VPP power rail. I should expect kilo ohms here. 1.8 volts. CPU power rail. Let's see 5-volt dual on this large MOSFET. Okay, here we go. It looks like we found a shorted power rail. 5-volt dual rail is a standby 5-volt power supply that remains active even when the main system is turned off. Okay, let's check. Let's measure also 3-volt standby rail. This is a second large MOSFET on this part of the board. Okay, this rail is not shorted. It's a good to have. Next, I'll check the resistance on the main capacitors around the chipset. If we see a very low reading or a dead short, that's a strong sign the chipset may already be gone. Kilo ohms is nice. Okay, and right here, oh, 16 ohms. Not sure if it's right or not. I guess it could be normal. Let's check resistance on the main capacitors around the SIO as well. Kilo ohms, nice. Okay, I'll proceed with the visual inspection. Okay, we don't have a USB socket over here. We need to solder it, remove the pins into solder socket, and we'll be successful with our repair. Since we haven't found any blown components or cracked capacitors, I'll inject 1 to 2 volts into the shorted power rail. Then we can inspect the board with a thermal camera to locate any shorted components that show up as heat source on the imager. I guess I can inject right here. Okay, to inject the voltage, I have this small power supply. I can set here 1 or 2 or 3 or whatever I need volts, and I can limit the current. So I guess we will set 2 volts or even 1 volt and 3 amps. I don't know, like if you will see all the board here. And inject. Right here, you see? Something is heating up. I guess we'll have to use isopropyl alcohol in this area to pinpoint the exact component generating the heat. So I will apply alcohol to this area, and we'll see what will be the starting point of evaporation. Injecting the voltage now. It looks to me the capacitor. However, let's try again. Let's remove it. Okay, let's check resistance now. Without that guy, and you see now it's 162 ohms, which is really nice. I want to power on the board and to see that short is gone. It usually can give us a picture if all standby power rails are working. I expect getting from 60 to 150 milliamps here. Here you can always see what memory goes first. Like first go A2 and B2. So usually it's this socket. Because when you have just one RAM PCB. Okay. Let's try to power it on. It's 100 milliamps. Okay, there is around 100 milliamps draw, which is normal. Let's measure voltages in standby mode before pressing power button. Okay, during the measure, I found a problem. I found a lot of missing components here, and this circuit is part of the chipset's power supply. I'm pretty sure that's what's preventing the board from starting up. Let's put all the missing resistors and capacitors here. Okay, I've soldered all the missing components, so in theory, this circuit should be good to go. Now the real test, let's power it up and see if we finally get a pause screen. As we already checked that none of the power rails are shorted, and this time I'm skipping the bench power supply and going with the regular power supply. So from experience, some motherboards are peaky at startup. They can pull big current spikes that my lab power supply just can't keep up with. By using a regular one, we can be sure the board's getting all the juice it needs. So, okay, what's the connector here? It's here. So if it still refuses to pause, we'll know the power source isn't the culprit. Okay, let's power it on. I will show you the pause screen here. And try and pull that. And here we go. Guess I need a large heatsink. And here we go. Here we go. Finally, we have the pause screen. So I guess the board now is ready to be assembled and tested. I'm not sure that I will do it right away, but rather I show the assembled and working device. Okay, I've cleaned up the board, reassembled everything, and tested it in Windows. All features are working exactly as they should. All USB ports are working, HDMI DisplayPort, inner headers, including that USB damaged connector. From the look of it, I think a capacitor shorted out, and the previous owner probably knocked off a few components with a screwdriver while trying to remove the GPU or take the motherboard out of the case. So it doesn't seem like this board has ever been to a repair shop before, which honestly probably made my job a bit easier. Thank you for watching. If you enjoy this motherboard repair journeys, don't forget to like, subscribe, and drop a comment about the weirdest damage you've ever come across on a board. See ya!